Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In this video, we are going to start the unit 2nd of subject Microcontroller Architecture and Programming. The name of the unit 2nd is the Programming Model of 8051 Microcontroller. Let's start our today's topic, the instruction syntax for the assembly language programming. The instruction syntax consists of following parts: label, mnemonic, operands. There are two operands: source, destination, and commit. Okay. Now let's see description of each part one by one. The first part is label. Then what is meant by label? Let's see. The label is used for the instruction titles, procedure names, and variable names. Assembler translates these labels into the memory addresses. That means, in short, we can say that the label is the title of the instruction, and these titles are translated into the memory addresses by the assembler. The second part is mnemonic. The mnemonic is the instruction code names. It tells the type of the operation to be performed by the CPU. For example, for move operation, we write MOV. For addition operation, we write ADD as mnemonic. For jump operation, we write JMP as mnemonic, etc. The next part of the instruction is the operands. Generally, the operands are the variables on which the operation is to be performed. There are two types of operands: source and destination. And the last part of the instruction is comment. It is not the part of the instruction. It is not assembled. The comment is preceded by semicolon. That means comment is the not necessary part of the instruction. It is not necessary to write each comment for each instruction. Okay, it gives the instruction or the information about the instruction. Okay, now let's see one example here. Start add R0 with A, and the comment is addition of the content of R0 with accumulator. Here the start is the label. Add, that means the operation to be performed is the add, means addition operation. R0 is the source operand. A, that means accumulator, is the destination operand, and the comment is addition of the content of R0 with accumulator. That means this instruction tells us that in that instruction the addition operation is performed between R0 and the accumulator. I hope you all understand the instruction syntax of the 8051 microcontroller assembly language. Now let's see the addressing modes of the microcontroller. The different techniques or ways used to specify the address of the operand or data in the instruction are known as the addressing modes. The 8051 microcontroller provides following addressing modes such as immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, indexed addressing mode, and relative addressing mode. Let's see the details about each addressing mode one by one. First of all, let's see the immediate addressing mode. When the instruction is executed, the operand comes immediately after the opcode. The immediate data must be preceded by the pound sign, or we can also call it as the hash sign. That means the instruction which contains this sign is generally the immediate addressing instruction. This addressing mode can be used to load the information into any of the register, including DPTR. The instruction using immediate addressing mode are executed quickly, simpler to use, but they are not flexible. Okay, let's see the examples of the immediate mode. This in this example, here move is the mnemonic, a and 0 are the operand. Here the hash sign is given, that means this instruction is of immediate addressing mode. The meaning of this instruction is put 0 in the accumulator, that means put 0 in the accumulator. Now the next instruction is put 0 in the accumulator. The next instruction is move R4 comma hash 11H, that means move immediate data 11 into the R4, put 11 hex in the R4. After execution of this instruction, we get the value in the R4 as 001 0001, that means 11H. Okay. Now the next example is third, move B hash 11. Okay. The meaning of this instruction is put 11 decimal in the B register. Okay. This hash shows the instruction is of the immediate addressing mode. After the execution of this instruction, we get the data in the register B as B 00001011. Okay, here H represents the hexadecimal value, hence we put 11 as 0001 and 0001, but here H is not written, hence it is considered as the decimal value, and the decimal equivalent of 11 is 1011. I hope you all understand the difference. Let's see one more example here. Move dptr hash 7521H, that means load the 7521H value in the dptr register. Okay. After the execution of the instruction, the dptr has the value 7521 in binary. This instruction can also be written as move dpl, that means dptr low byte hash 21H, that means 21H data immediately loads into dpl register. Okay. After execution of this instruction, we get the 21 value into the dpl. Similarly, we can load data immediately into the dph register. Okay. dph means dptr high byte. Now let's see the next addressing mode, register addressing mode. In this addressing mode, the instruction specifies a register where the operand is located. Either the source or destination is one of the CPU register. We know that there are total 8 CPU register in each register bank R0 to R7. Okay. In this type of addressing mode, either source or destination is one of the CPU register. The instruction using this addressing mode requires less memory space and are executed quickly. For example, move dptr, a is invalid because we know that dptr is a 16-bit register and a is 8-bit register. Hence, here the size mismatch occurs. Hence, this is the invalid instruction. Similarly, move R4, R7 is also invalid instruction because in this instruction both the operands are the register. We require only one operand is register while other is another type. Let's see some examples of the register addressing mode. Okay. First example is move R0, a. That means here in this instruction we can identify, here is 1 in each instruction. 1 is a register. Here is R0, R7, R4, R7, etc. This type of instruction is known as register addressing mode. Okay. This instruction is move R0, A. That means save the accumulator into the R0. Move the content of accumulator into R0. The next instruction is move A, R7. That means move the content of R7 into the accumulator, or the content of R7 into accumulator. The next instruction is add A, R4. That means addition of R4 with accumulator. The next instruction is add A, R7. That means addition of R7 with accumulator. Now there is one more example. Move dptr hash 25f5h. We have to understand this is the instruction of immediate addressing mode because the hash sign is used here. Okay. Now when by using immediate addressing mode we load the value 25f5h into the dptr. Okay. Now we want to move this data into the register by using register addressing mode. Here in this instruction move R5, dpl, one register is used, hence it is the instruction of register addressing mode. The meaning of this instruction is load F5 into dpl. Similarly, this instruction move R6, dph is of the register addressing mode, and which means that load 25h into dph into R6. I hope you all understand the difference. Let's see once again. Here is the hash sign is given, that means this is the immediate addressing mode, and here is one operand is register, hence this is the register addressing mode. Okay. Now let's see the next addressing mode, direct addressing mode. In this addressing mode, the actual address of the operand is specified as a part of the instruction. By using this mode, we can access internal RAM and SFRs directly by providing an 8-bit address. This mode is commonly used to access internal RAM locations 30H to 7FH and the SFR address 80H to FFH. The direct addressing mode is used in the stack. That means in this diagram we can see here the memory address 00H to 2FH are used for bit addressable memory and the general purpose register. Hence, above this value, that means above 2FH, from 30H to FFH, we can use the direct addressing mode. Let's see some examples of direct addressing mode. Okay, direct mode specifies the data by its 8-bit address, usually for 30H to 7FH of RAM. The first example is move A, 70H. Okay, this instruction is similar as the immediate instruction. If the hash sign or the pound sign is preceded by the 70H, then this instruction becomes immediate addressing, but here this sign is absent, hence this is considered as the direct addressing mode. Here the 70H means the memory location of 70H. Okay, now let's see the example move A, 70H. That means whatever the data in the 70H location is moved into the accumulator. That means copy the contents of the RAM location at 70H to accumulator. Here is, this is the memory location. Okay. I hope you all understand the difference. Let's see once again. Here 70H, 40H and 56H are the memory locations, not the actual data. Okay. Now let's see the next instruction. Move R0, 40H. That means copy the contents of the RAM at 40H to accumulator. The next instruction is move 56H, A. That means put the contents of the A at the 56H to a RAM location. That means move the content of the accumulator to the 56H location of the RAM memory. I hope you all understand the difference. Let's see another examples here. Move 0D 0H, A. Here 0 is placed before D alphabet because it is the syntax of the assembly language programming, in that when we use the alphabet, then we have must write 0 before using it. Okay. Move 0D 0H, A. That means put the contents of accumulator into the PSW register. This is the address of the PSW register. Okay. Move ATH, A. That means copy the content of accumulator to port 0, where ATH is the address of the port 0. Similarly, move A, 02H and move A, R2. These both instruction gives the same result, because the meaning of these two instructions is that copy the content of the register R2 or the memory location 02H into the accumulator. I hope now you can all understand the direct addressing mode. Okay, let's see a short look on the addressing mode. First of all, let's see the immediate addressing mode. In immediate addressing mode, we use hash sign. For example, move A, hash 20H. That means load the data 20H directly into the accumulator. Okay. Now next instruction is the second addressing mode is register addressing mode. In register addressing mode, it is compulsory that one of the operand must be a register between R0 to R7. For example, let's see move R7, 60H. That means whatever the content of the memory location 60H is moved into or copy into the R1 register. And in direct addressing, the example of the direct addressing, the direct means the direct RAM location. Okay. For example, move A, 30H. This meaning of this instruction is that whatever the data stored in the RAM location 30H is loaded into the accumulator. This is known as the direct addressing. I hope now immediate addressing, register addressing and the direct addressing is clear. Let's proceed. The next addressing mode is indirect addressing mode. In this addressing mode, the instruction specifies a register which contains the address of the operand. A register is used as a pointer to the data. When the data is located inside the CPU, only registers R0 and R1 of the selected register banks are used to hold an 8-bit address. Here, the one important thing is that the registers R2 to R7 are not used for the pointer. We can use only R0 and R1 as a pointer. When the data is located in the external RAM, it requires 16-bit address. For that purpose, DPTR register is used. While using R0, R1, DPTR register as a pointer, they must be preceded by the @ sign. This is the mnemonic symbol used for the register indirect addressing mode. Okay, that means in indirect addressing mode, we can use a pointer. When we use the internal RAM, then we can use R0 and R1 as the pointer, and when we use the external memory, then we can use the DPTR as a pointer. Let's see the examples of the indirect addressing mode. Move a comma @R0. That means move the contents of the RAM location whose address is held by R0 into accumulator. Okay, this means @R0 means that R0 is a pointer and it points the memory location. Whatever the data stored in this memory location pointed by the R0 is loaded into the accumulator. Okay, move @R1 comma B. That means move the register B contents into the RAM location whose address is held by R1. The next instruction is move x @dptr comma a. Here is the move instruction is used, but here move x instruction is used. Why this? Because the move operation is done inside the memory here, but here we use the external memory. Hence, for the external operation, we use the mnemonic move x. Okay. The instruction is that move x @dptr comma a. That means save the accumulator in a memory location whose address is held by the DPTR register. I hope you all understand the difference between move and move x instruction. Let's see once again. The move instruction is used when the data is moved inside the internal memory, but when we use the external memory, then we have to use move x instruction. Okay, now let's see the another examples. Here uses the register R0 or R1 for 8-bit address. Move PSW hash 0. That means we can identify this instruction. Here the hash sign indicates the immediate addressing mode. Okay, that means the use register bank 0. The next instruction is move R0 comma hash 0 cross 3C. That means used R0 as the pointer, and now the R0 points the memory location 3C. Okay, now move @R0 hash 3. That means move the data 3 to the pointer. That means move the data to the memory location 3C. Similarly, we can use the DPTR register for 16-bit address such that move DPTR comma hash 0 cross 9000. That means DPTR is used as a pointer for the memory location 9000H. Now move a comma @dptr. That means the data pointed by the DPTR, that means the data in 9000H is now moved to the accumulator. Here the move x instruction is used. That means we used here the external operation. Okay, note that the 9000 is an address in the external memory. The next addressing mode is indexed addressing mode. The register indexed addressing mode is widely used to access the data stored in the external RAM or in the program code memory. In this mode, the 16-bit registers like DPTR or PC are used as data pointers along with the accumulator. Source or destination address is the sum of the base address and the accumulator, and this sum is referred as the index. The move C only can read the internal code memory. Okay, let's see the examples. Move C a comma at the rate a plus dptr. Here this is the index is used. During the execution of this instruction, the contents of the accumulator are loaded with the dptr to generate the operand address of the code memory. Then the data is stored in the accumulator. Similarly, the second instruction is move C a comma a plus PC. This instruction is used to access the data elements of the lookup table. Note here the move C instruction is used. Okay. Now let's see the another examples of the indexed addressing modes. Base address can be DPTR or PC. Move DPTR comma hash 40,000H, that means move 40,000H value into the DPTR. Value means 40,000H into the DPTR. The next is the meaning of the instruction move DPTR comma hash 40,000H means the DPTR is assigned as a pointer for this location. Now move a comma 05H, that means 05, that means load. Now the accumulator contains 05. Okay, now we can make the pointer or index such as by adding these two, a plus dptr, that means dptr contains 40,000, 4,000 and a contains 5, the index becomes 4005. And move C a comma at the rate a plus dptr. Okay. Now the next addressing mode is implied addressing mode. In this addressing mode, the operand address is not provided in the instruction. It is determined by the instruction functions itself. For example, DAA, that means decimal adjust accumulator. RRA, rotate right contents. CPLA, that means complement accumulator. Okay. The next addressing mode is relative addressing mode. It is used only with certain jump instructions. A relative address is 8-bit sign value which is added to the PC to form address of the next instruction. The range for the jumping is -128 to 127 locations. That means the relative addressing mode is used in the jump instruction and the range of the jump is -128 to 127 location. The example of the relative addressing mode is SJMP, that means short jump. Here is the label. Okay, I hope you all understand all the addressing modes used in the assembly language programming of 8051 microcontroller. Thank you.